Hello and welcome back. Today we're talking about the bias variance trade-off. All right, so here we've got the same data set 3 times and we're going to apply 3 different models and see what we think of them. The first model will be applied to the data set like this. Now this, even though it's hitting every single point in the data, is not great because it's overfitting. It's got what is called high variance. And the way to remember that is that if you change this data, so let's say this is training data, and if you change this data, if this training data is changed, then the model will vary. So it's very highly fitting, it's overfitting to the training data. And so it varies a lot if the training data is changed. So this is called overfitting. The model varies a lot if the training data is changed. The symptoms of this, how can you tell if your model might be overfitting, is it performs very well on the training data. You get great results, but performs very poorly on the test data. And that's another reason why it's important to have both training data and test data to verify that your model is, in this case, not overfitting. Or in this case, it is overfitting. Model 2, this one is got high bias and is basically predicting, in this case, a very, very high bias. It's a very basic model. The model is too simple. It's just predicting the same answer for all the points. So it's fit this line, this horizontal line is just taking the average of all the values. That's still a model. It's an average model, but like it uses the mathematical average as its basis. But it's a bad model because it's underfitting. It's not seeing any of the patterns, underlying patterns in the data. It's not capturing the underlying pattern. The model is too simple, and the symptoms here are it's got bad performance on the training data. As soon as you see bad performance on training data, there's a chance your model might be underfitting, might be too simple for your data set. So in the case of this model, it's too complex. Because of its complexity, it's like its sophistication, it's able to capture all the training data, but that's also not good. In this case, it's too simple. And then finally, model number 3, as you can see here, it's capturing an underlying trend, underlying pattern in the data, but it's not too simple, not too overfitting or too sophisticated that it's overfitting. So it's got a good balance. And this is called a model is well balanced. The symptoms are model performs well on both training and test data. So that's 3 things. So this is the trade-off between bias and variance. Another way that sometimes this is explained is through the bullseye diagram. So here, imagine you've got bias, low bias here, high bias on the vertical axis, and then on the horizontal axis, you've got low variance, high variance. So imagine you're throwing darts at a bullseye, at a target. So if you're constantly throwing darts and you're hitting them all close together, but away from the center, then you have an underfitting situation. If we're talking about models, your model is underfitting. It's got a high bias, but a low variance. Now, if you've got a different situation where you're throwing the darts and you're kind of around the center, but your darts are all over the place all the time. They're not all clustered in the center. They're all at different locations all the time. That is an overfitting model. That means you've got low bias, high variance. If you change the training data, the pattern will change again. It'll kind of be around the center, but the points are never going to be clustered together. And if you have low bias and low variance, then you're hitting the bullseye all the time. You're very close to it. That's a good balanced model. And of course, the opposite situation, if you have high bias or high variance, you have a terrible model. You're far away from the center and everything's scattered around. So that's another way it's explained. Personally, I prefer the first way that we looked at. Nonetheless, here's a quick summary of what we discussed. And that's all you need to know for the exam. And I look forward to seeing you back here next time. Until then, enjoy the cloud.